I am Stefano Tomasin, and this is the tutorial on key technologies for next generation digital video broadcasting standard. I am assistant professor at University of Padova with the Department of Information Engineering, and I would like to acknowledge for the preparation of this tutorial Professor Lorenzo Evangelista from the same department, and Dr. Matteo Butussi from Abilis Systems in Geneva, Switzerland. First, a notice. The information included in these slides is deemed as accurate at the date of publication. Such information is supplied for merely educational purposes and may not be used in designing systems, products, networks. In any case, these slides are subject to change without any previous notice. The author does not assume any responsibility for the content of these slides, included but not limited to accuracy, completeness, enforceability, updatedness of information thereafter provided. First, before discussing the key technologies of the new digital video broadcasting standard for terrestrial application, shortly DVB-T2, we discuss why there was a need for a new digital video broadcasting standard. Before the publication of the DVB-T2, there is already an existing standard which is nowadays deployed in most of European countries and also in other parts of the world, which is DVB-T. So why moving to a new standard? Well, first there was a pressure from DVB-S2 service provider to terrestrial service providers. Recently, a new standard for the digital video broadcasting on satellite system has been defined, DVB-S2, and the constant competitivity between satellite and terrestrial transmissions has suggested also the release of a new standard for DVB-T. What are the requirements of the new standard? First, use existing domestic receive antenna installation. When designing DVB-T2, the intention was to create something that would require only the change of the set-top box in each home and not going to the rooftop and replacing the existing antennas. Second, target services to fixed and portable receivers. So the option for mobile receivers is out of the scope because there is already an existing standard which is DVB-H, DVB for handheld application, that support the transmission to mobile devices. So the focus is on fixed and portable. Third, provide a minimum of 30% capacity increase over DVB-T under the same planning and conditions. Condition means the channel condition here. This capacity increase by at least 30% is meant mainly to provide high definition television, but also other services that may be conveyed within DVB-T. Improve single frequency network performance compared to DVB-T. The single frequency network is designing architecture for digital video broadcasting standard, where an area of the territory is covered by many transmit antenna, many base station, and each of these transmit antenna, each of these base station is actually transmitting the same signal at the same time on the same frequency. So what is received is the superposition of the signals. In DVB-T, this solution, which has been widely adopted, has shown some limitation, and a desire for the design of DVB-T2 was to improve the performance over SFN networks. Then another request another requirement is to provide service-specific robustness, so being able to differentiate the robustness in terms of coding rate, for example, and protection against error. Differentiate this robustness according to the kind of services that may be provided, with the possibility of providing more services with different robustnesses. Then provide bandwidth and frequency flexibility. The need of using different frequencies and different bandwidth in accordance to the regulation imposed by single states is felt as a requirement for DVB-T2, but this is relatively easy to be implemented. Another request, this request is coming explicitly from the broadcaster. Reduce the peak to average power ratio of the transmitter signal. In DVB-T, we will see this point in more detail in the following. The modulation format that was used has a high peak to average power ratio. That means that the transmit power may have some very high peak with respect to the average transmit power, and this forces the use of expensive amplifiers. So one of the requirements for DVB-T2 was to reduce this peak to average power ratio. What are in practice the benefits of DVB-T2 versus DVB-T, versus the new generation of digital video broadcasting standard with respect to the first generation of digital video broadcasting standard? First, a capacity increase of almost 50%. So the requirement was to increase the capacity by 30%, but in practice the capacity increase is much higher. For example, this is an example that is employed in UK. It is possible to go from the current 24 megabit per second to the 36 megabit per second, and for single frequency network the increase is even higher, up to 67%. So this is the main benefit of DVB-T, in addition to the flexibility and all the nice features that have been requested as requirements. So no change of the existing infrastructure, and some additional benefits in terms of flexibility and reduced peak to average power ratio. Here we see a table of achievable data rate in megabit per second for some DVB-T2 configuration. We will discuss this number in more detail in the following. What we see here is three different configurations characterized by FFT size, so the OFDM size, and guard interval size, and pilot pattern, so how much pilots, that means signaling information for channel estimation, is inserted into the signal, is used. Different code rates of the low density parity check codes, we will see them in more detail in the following, and different constellation used for the modulation, which are the 16 QAM, 64 QAM, and 256 QAM. We will see again we will discuss all these choices in the following. What we would like to emphasize here is the data rate that may be achieved in megabit per second by this system. We have values that range from about 18 to 45 megabit per second, according to the different code rates and modulation that are used. So there is really a huge huge capacity available. Let's start looking at the architecture now of the DVB-T2. Here we see a picture that shows how we go from the input program signal, which is for example an MPEG signal, down to the modulation of this on the distribution network, on the